Hi folks, welcome to the another episode of Fix My Kubernetes Cluster. Yeah, let's get started. So I don't have any cluster with me. I'm creating a new cluster with an issue. The cluster has been created, and the core components like etcd, AP server, everything is ready now. Yeah, so the namespace is ready. The engine export has been created. Now we are deploying the utils to utils pod to for debugging purpose. Okay. Yeah, if you see now, like we are trying to run this command working service, and it is working now. I'm expecting it to be not working, but it is working. Okay, there was a issue with the issue that it was expected to create. So I fixed it now. Behind the scenes now, it is not working the working service. We want to fix it. If you see here, it's a connection timeout. So which means the DNS is able to resolve. And let's see if the service is having endpoints. Kubectl get SVC. Working SVC. Okay, it is having. Does it have endpoints? So let's do describe. Yeah, it has endpoints. So which means if I try to maybe directly hit this endpoint, it's not working after 5 seconds. Yeah. So basically, from the util pod, we are not able to reach this IP, and it's failing. We can cross-check in this IP. We can exec into this pod and see if this Nginx is running or not. So in this case, it is running. So we are not checking that one. Now, why we are not able to reach it, right? So let's see if kube proxy is there, similar to last time, whether it is writing these rules for the SVC to the pod IP. If we see here, the kube proxy is running, so which means probably the rule should be there. Let's quickly check that, right? So docker ps docker exec -it 5ea bash. So let's do IP tables of type NAT. Let's do listing of type pre-routing. So let's do kube services. For the kube service, we want to do for SVC the 57. So which means here I'll be using this bxx. Here, if you see, we have a rule that is already there, the IP table rule saying if it is this IP, go to this 197, which is nothing but the pod IP, the 197. So which means IP table rules are there, but still we are not able to reach it, right? So here, similar to NAT, we have another type called filter. So let's do this filter and see if we find something problem with this filter type rules. Let's grep for the destination 197 with context say 4. So context capital C for grep. Oh, filter, I have to do the listing. 197, probably it is not there. Then let's do. So I'm gripping for 5.5. I'll let you know what is this 5.5 soon. So I'm just gripping for 5.5 with context. 5 looks it's not enough. So let's add more context. Okay, so this 5.5 belongs to this this chain of rules. So in this case, if you see, it is allowed only from this source to anywhere. If it is anything else, it will return, or there is another rule saying like this, right? So basically, let's not try to understand more about this IP rules, but we have an IP rules for this 5.5, right? And basically, I don't know more about this filters chain and all. So basically this is something, so similar to NAT rules, we have this filters. So who is creating these filters, right? So if I do, so in here I'll do kubectl get network policies, network policy. So if you see, we have one network policy that is defined. Let's try to see what is the definition of this network policy. Let's see if describe helps here. Yeah, so it says if we want to reach, so this network policy is applied to all these pods which are having app equal to Nginx. It is saying allowing ingress traffic to this port only from this IP block, and if it is from the pods which are having the role equal to front end. So all other ingress are blocked for this app equal to Nginx pod. There is no effect of egress because it is of there is no change, and it is of type ingress type. So which means if we do get pods hyphen show labels, yeah. So which means for this app equal to Nginx pod, this network policy is applied, and it will allow only from this IP or any pod that is having this IP. So in this case, let's see if I don't know if we search for front end, it will not come because we are saying okay the label is front end. Yeah, they don't have this, but this filtering is what happens here. So if you see this IP 5.5, it's /32, so it's a single IP. So there are rules for this IP. So similarly, based on these labels, the Calico. So we are using Calico based networking, CNI. So Calico is doing some pre-routing based on that it is dropping and it is not allowing it. So maybe we can deep dive in the next episode or to understand how to read this chain rules to know that okay this is getting dropped, or maybe we can use some TCP dump and see how it is getting dropped. But again, that is more internals of Calico. But at high level, right, Calico is using this filter based IP table rules to filter out based on this IP restrictions we add, the policies we add. Right now, let's try to add the label for our utils pod and try to reach it now. So let's do kubectl label for the pod. So we are going to, okay, let's copy this name. So we are going to label this pod. The label I'm going to say, in the rule we say only allow which are having this role equal to front end. So which means we have to do role equal to front end. So it's added. So which means my utils pod is having this role equal to front end, which means now it should allow. So let's try to do the curl request. Let's do the curl request directly to the DNS name from the utils pod. Yeah, now because the utils pod is having that label, it is allowing. So this is the network policy we define, which we already spoke about it. Now you can add more rules here, like I want to allow from another pod selector, or I want to say anything that is running on this node namespace. So here we say, okay, any namespace that is having this label, I can say front end namespace. So all namespace which are having this label, all the pods that are running in this namespace will be able to achieve it. So we can add namespace labels to the namespace also. So another rule, if I want to show you here, it is a combination of namespace and it's an uncondition. So here what we are saying, in this namespace, whichever pod is having this label are allowed to access. So basically here it is like an only all these pods in this namespace, all these pods having this label. This is all these pods running in this namespace. This is like all the pods that are having this label and from this namespace. It's like, yeah. So whenever you write this network policy, it's like be very cautious about this array of elements. So here it is like a single element is having both the rules. Here each element, this is a pod selector rule, this is a namespace selector rule. So make sure that you specify these rules very carefully. Similarly, you can have egress rules to say, okay, from this util pod or from this Nginx pod, what are the traffics allowed, right? I can say my Nginx can only talk to the database. My Nginx cannot talk to any other service, right? So you can put an egress rule saying, let's write that right very quickly. If I want to say, I can say this egress is to, I can say again pod selector, match labels, I say role equal to database. Yeah, so what is this use of this extra network policies we add, right? So in this way, you control who can talk to whom. So in this way, we reduce the surface area of our attacks. For example, right, if somebody is able to exec into the front end pod, somehow, right, the attacker is able to exec into the front end pod. Now, in this case, they can only exec, they can only try to talk to the database the front end can talk to, but all other database, all other services are not exposed, right? So even if some a part of our pods are compromised or our application is compromised, we are restricting the attack area by using this network policies. Even if you have multiple teams, right, you can specify, okay, this team can only talk to this team. Other teams cannot put so much load on my team, right? So all these things we can achieve using this network policies. So one catch here, if you want to apply this network policy and you want to work on it, so you have to use the CNI which supports this network policy. So in this case, I'm using Calico. So if you see in the previous episodes, we were creating the Kubernetes cluster just by using kind create cluster. But if you see in this case, we did kind create cluster with this configuration file. If I quickly show you what is this configuration file look like, we say disable default CNI. In the previous episodes, if you remember seeing, the CNI will be kindest net. So we were using the kind based CNI for the cluster. But in this case, because I want to, because that doesn't, because kind is just for an development purpose, right? It doesn't support network policies. So for this problem statement, we installed the Calico project Calico based YAML. So if you see, we create the cluster, then we install the Calico CNI. After that, only node will become ready. So that's why instead of checking for node to be ready, previously we were checking node for ready. In this case, we are checking whether these two parts are ready. Once these two parts are ready, we will apply the Calico. After that, the node will become ready. So here we are waiting for the Calico, the daemon set to be rolled out successfully in all the nodes. Then here we are waiting for the namespace to be ready and other things. And we are trying to create the Nginx, and we saw the problem. After we applied the label, it started working, the expected front-end label. Yeah, you can see more about this network policies page, that the Kubernetes official page, where we talk about ingress rules, egress rules, how to specify the pod selector, the node, the namespace selector, how to specify both the things, right? IP block, what is the default value, right? So if you apply rules, what is, whether it is deny default or allow all egress. So be careful about applying this one. Better to read in detail about this one before applying the network policies. Yeah, you can understand more about how it is happening behind the scenes from this page, Kubernetes networking with Calico. It looks useful. And you can read about the IP table rules. What are the different types of controls IP tables provide? And you can play with this. Probably you can play more with this to understand how Calico is using manipulating these IP tables in order to achieve this network policies and network translation from SVC to pod IP and everything. Yeah, hope you like this content. Like it, share with your friends. Comment if you have any inputs for me to improve or suggestions so that we can work on the upcoming episodes. Thank you for watching.